You know, when you think of a musical genius, you probably picture someone pouring their soul out at a piano, a masterpiece just flowing from pure inspiration. But what if I told you that's not the whole picture? What if some of the greatest music ever created wasn't born from chaotic passion, but from a code, from a set of rules?
I know, it sounds almost blasphemous, right? Mozart, the guy who basically is the definition of genius, using dice to write music? But it's absolutely true. And he wasn't alone. This idea of using a defined process, an algorithm, to create art has been hiding in plain sight for centuries. Let's dive in and see just how deep this rabbit hole goes.
So take a look at this. On the left, you've got a flowchart for a math problem. It's logical, it's step by step, exactly what you'd call an algorithm, right? But then, look at the one on the right. That's not math. That's the structure of a medieval song from the 14th century. It's also a flowchart, a super strict follow-the-steps process. This just goes to show you, the whole idea of an algorithm isn't some newfangled computer thing. It's been a tool for artists for, well, centuries.
All right, Section 1. Music Secret Algorithms. We're going to dig into the hidden rules that shape some of the greatest masterpieces ever written.
So what exactly is an algorithm? At its heart, it's just a recipe, a set of rules to solve a problem in a certain number of steps. The word itself, algorithm, actually comes from the 9th century mathematician Al-Khwarizmi. But the idea, just a method for getting from point A to point B, that's something composers have been using forever, whether they called it that or not.
And believe me, this isn't a new trend. This goes way back. You've got the 14th century, where those strict song forms we saw were basically musical flowcharts. Fast forward to the 17th century, and you have literal music-making machines. Then the 18th century, which gave us those famous musical dice games from guys like Mozart and Haydn, mixing chance with strict rules. And it doesn't stop there. In the 20th century, you get stuff like serialism, where an entire complex piece is built from one single 12-note sequence. That's the core algorithm.
The musicologist David Cope really nails it with this quote. So, the big idea here is that creativity isn't always about pulling something out of thin air. It's often about recombination, but doing it with subtlety and elegance. And that idea, elegant recombination, is what connects this long history of rules in music right to the world of AI.
Okay, Section 2. Now we're jumping into the modern era to talk about teaching a computer how to compose. And we're going to focus on David Cope's incredible program, which he called Experiments in Musical Intelligence.
So, how in the world do you teach a computer to compose like, say, Bach? Well, Cope's method was kind of like a 3-step recipe. Step 1, the database. You basically feed the computer a massive diet of one composer's music. Let's say all of J.S. Bach's chorales. Step 2, recombination C. The program then chews on all that music, it breaks it down into tiny pieces, and starts to learn the composer's grammar, the rules of how the notes connect. And finally, Step 3. It finds the fingerprint. The computer looks for these unique, recurring patterns. He calls them signatures, and it learns that these are special and need to be protected.
Now this is the really brilliant part. See, Cope didn't sit down and try to program the rules of Bach into the computer. People had tried that before, and honestly, the music it produced was pretty stiff and lifeless. Instead, his AI learns. It infers the rules directly from the music itself. The style, the voice, even what you might call the soul, it's all pulled right from the source.
Which brings us to Section 3, finding a composer's fingerprint. So let's talk more about this signature. What is it really? What's the secret sauce that makes the AI's music feel so authentic? Okay, so a musical signature, it's way more than just a composer's favorite chord or a little melody they like. Think of it like a poker player's tell, right? That little twitch they can't help. It's a unique pattern they keep coming back to across lots of different pieces. It's a key part of their musical DNA. And finding these, that's the secret to making the AI's version sound convincing. Let's look at a real example from Mozart. It's fantastic. So Mozart had this habit, a little trick he used to end his phrases. He'd bring in the home bass note just a little bit too early so it creates this really beautiful intentional clash with the chord playing above it. It's such a clever way to build and release tension. Cope's program is smart enough to spot these kinds of signatures and then learn how to use them, just like Mozart did.
Okay, But this probably brings up a big question for you. I know it did for me. If the computer is just recombining old pieces and protecting these patterns, is it really composing, or is it just a super sophisticated copy and paste machine? Can we actually call that creative?
That leads us right into our next section, the creative spark. Can a machine actually invent something new? And this, my friends, is where things get really mind-blowing. Because the machine doesn't just copy and paste, it does something more. It infers. And inference, that's the secret ingredient that lets it create something that feels genuinely new.
So, what is inference? It's basically the ability to look at all the data and then generalize from it, to figure out the underlying principles. It's not about just following the rules it was shown, it's about creating new rules based on what it learned. You know, it's like the difference between memorizing a few phrases from a travel phrase book versus actually learning a language. Once you know the language, you can say things nobody's ever said before, but everyone still understands you.
Let me show you what I mean. The program looks at thousands of tiny musical bits and pieces from its database, all these little chord-to-chord movements. From all of those examples, it starts to infer the unspoken rules of harmony. It learns why certain notes move to others, and then it uses those rules it figured out on its own to build a completely new musical progression, one that literally never appeared in the original music but sounds perfectly, logically, in style. That's not copying, that's creation based on learned knowledge.
So why does this work so well with a composer like Mozart? It's because even a genius like him has an underlying logic. Think about it. If you ask a computer to predict the next note in just a random jumbled melody, it's basically guessing. Its accuracy is like 12%. But give that same computer a melody by Mozart, the accuracy jumps to over 70%. Now, that doesn't make him less of a genius. It just proves that his style is a coherent, learnable language. And that makes it the perfect raw material for an AI to learn from.
But okay, does this mean the machine is actually intelligent? This gets us into the whole philosophical debate around the Turing test. You know, the idea that to pass as human, a machine might need to do more than just be smart, it might need to act convincingly human, flaws and all. So instead of spitting out a perfect sonnet on demand, maybe a truly human AI would say, "Oh, I'm terrible at poetry." Instead of adding two huge numbers in a nanosecond, maybe it would pause and maybe even get it wrong. It's a real philosophical puzzle. Is intelligence about perfect, instant answers, or is it about believable, sometimes flawed behavior?
But at the end of the day, the goal of a program like this isn't really to fool us into thinking it's a person. It's to be a powerful new kind of tool, a creative partner that can analyze, associate, and adapt musical ideas in ways we've never seen before, to help us generate something completely new.
And Alan Turing himself, the father of AI, really put his finger on the ultimate hurdle. He was quoting a surgeon named Jeffrey Jefferson, and he said, "The real test isn't just composing the concerto, it's composing it because of thoughts and emotions you actually feel." And that, well, for now, that's still something uniquely human.
So while we can debate the philosophy all day, the raw power of this technology is staggering. Get this, in about a single month, one version of Cope's program composed 5,000 symphonies. 5,000! The sheer scale of that creative output is it's mind-boggling.
Which brings me to a final thought. Maybe this whole time, we've been asking the wrong question. Maybe the real question isn't, can a machine be creative?
Maybe the only question that really matters is this one. If a piece of music moves you, if it makes you feel something powerful, if it brings you joy or maybe even makes you cry, does it really matter where it came from? Does it make any difference at all whether it was born from a human soul or from a silicon chip? I mean, what is art anyway, if not the effect it has on us?